In this video, I'm going to talk about Norton Theorem. Norton Theorem is similar to Thevenin Theorem. We're going to convert a circuit into a simple current source in parallel with resistor. So if you remember the Thevenin Theorem, we convert a circuit, equivalent circuit, into voltage source in series with the resistor. Here we're going to convert that into a current source in parallel with the resistor. So we already know source transformation theorem. By using source transformation theorem, you can convert voltage source in series with resistor into a current source in parallel with resistor. Resistance value does not change, resistance is same, but the current value is going to be V Thevenin over R Thevenin. Thevenin is a person name who invented the Thevenin theorem. Same thing with Norton. Norton is the person name who invented the Norton theorem. So here is the first example. In this example, he's asking about find the equivalent circuit across AB terminals. So in Thevenin theorem, we had 4 steps. So it's similar to Thevenin theorem. We're going to do the 4 steps. In Thevenin theorem, step 1, we always remove where we need to find the current or voltage. We'll remove that element and label the terminals, right? That is our step 1. Here also same. So remove the element. Instead of open it, here what we're going to do, we're going to short circuit it. That is the difference between Thevenin theorem or Norton theorem. So here I'm going to short circuit it. I'm going to find the I Norton current. Now 8 ampere current is coming from the source. Okay, so if I redraw the circuit diagram is like this: 10 ohms and 20 ohms. Now A, B are short circuited, so it is kind of same voltage. In reality, say for example, this one has 10 volt. This will be, one of them will be like 9.9999 volt. That's how there will be some current passing through it. Otherwise, it could be 10 volt and this might be 9.9999 volts. So current can be go through from B to A. Usually, if it is the same potential, there won't be any current flow. But if there is a wire and current passing through it, that means there is some potential difference. That potential difference might be very small. Okay, these numbers, those are hypothetical numbers. Those are not the actual values. Now, I draw the equivalent circuit right here. So if we look at here, this is the equivalent circuit. Okay, what I did, since A and B are the same node, I connected it back. So current passing through 10 ohm, I10 equal to total current multiplied by opposite. So when there are 2 resistors in parallel, I can use the current division rule. So by using current division rule, 8 times 20 divided by total resistance, which is 10 plus 20. It gives me 16 over 3 ampere. So the current passing through 10 ohm is 16 over 3 ampere. Now the remaining current or current passing through the 20 ohms is 8 by 3 ampere. Okay, so here the current passing through it is 8 by 3 ampere. Similar way, I found the current passing through 50 ohm resistor, because whatever the current comes here, it's going to rejoin again 8 ampere. Again, it's going to split in 2 different ways. So I found I50, which is 8 multiplied by opposite resistance, which is 40 divided by total resistance 40 plus 50, which is 90, end up with 32 over 9. So the current passing through this is 32 over 9 ampere. Now my goal is finding I Norton. So what I did, I applied KCL at this node. 16 over 3 is coming in. 32 by 9 is going out. So I Norton must be 16 divided by 3 minus 32 over 9. End up with 16 over 9 ampere. So my I Norton equal to 16 over 9 ampere. This is my step 2. Okay, that is my step 2. In step 2, we find Norton current. Norton current is nothing but the current which is passing through the short circuit. 16/9. In step 3, step 3, find Orthovinia. So while finding Orthovinia, replace all independent sources with their internal resistance. Finding Orthovinia is similar to finding Orthovinia in Thevenin equivalent circuit. So here I want to find resistance between AB terminals. I will start walking from A. I'm going to split in two parts, so 10 and 50. Now, since this is open, whatever current goes across the 10 ohm or current passing through the 10 ohm is going to be the same current passing through 20. So those two must be series. 10-20 series, 50-40 series. So we'll end up with 30 ohms parallel with 90, which is 22.5 ohms. In step 4, draw the equivalent circuit. So I have a current source of 16/9 ampere and Orthovinia is 22.5 ohm. Now, whatever resistance we removed in step 1, we're going to connect it back here. But in this particular example, he asked us just find the Thevenin equivalent circuit across AB terminals. So we found the Thevenin equivalent circuit across AB terminals. So this is the Thevenin theorem. I'm going to solve another example here. Here is the next example. Find the current passing through the 12 ohm resistor by using Norton theorem. So he wants us to find this current I in 12 ohm resistor by using Norton theorem. So you can find out the Thevenin equivalent circuit and convert that Thevenin equivalent circuit into Norton equivalent circuit. I will give you full credit in the exam. However, I recommend you to solve it by using the actual method we used to solve the Norton equivalent circuit. So in step 1, what are we going to do? Step 1, remove the 12 ohm resistor, label the terminals A and B and short circuit it. I always take the current passing from A to B all the time. Now step 2 is finding I Norton. So what I did to find I Norton, I used the mesh analysis in this case. It's up to you. You can use mesh analysis, nodal analysis, it doesn't matter. So here my I1 equal to 2 ampere. So I use the mesh analysis because I already know I1 and I2. All I need to do is find I3. And I2 equal to -6 ampere. So those two we know because we know that as long as there is a current supplies or current source at the outer branch of the circuit, then we can take that as a current passing through that loop. So that's how I got I1 and I2. Now loop 3, apply KVL. So applied KVL here according to my I3. This is plus minus. So only those two elements in there. So I'm entering the positive terminal. So 5 times I3 minus I2. Whenever I'm on loop 3, I always take I3 current is larger than I2. And same thing, 8 times I3 minus I1. So I end up with 13 I3 minus 5 I2 minus 8 I1. But I already know I1 and I2. I substituted those values, ended up I3 equal to -1.076 ampere. So that is my Norton current. That is my step 2. Now step 3, find Orthovinia. So while finding Orthovinia, replace all independent sources with their internal resistance. If it is a current source, open circuit, voltage source, short circuit. Another important point is if there is a dependent source, keep it as it is. Now if there is a dependent source, we always connect a 1 ampere source to find out how much that dependent source is supplying, how much resistance that dependent source is supplying to the circuit. So that's another way. Here I do not have any dependent source. That's easy. So all I need to find are AB resistance between AB terminals. So start walking from A, reach B. So when I reach B, I end up with 8 plus 5. Those two are in series. So that's 13 ohm. Step 4, draw the Thevenin equivalent circuit. So here is my A and B. Remember that this current direction is always up because the load current must flow from A to B. Now this is Orthovinia, I Norton. So all I need is find the current flowing in 12 ohm resistor. So connect back the 12 ohm. So I Norton, or sorry, not I Norton, I load current, IL equal to total current multiplied by opposite over total resistance. So I found that current as 0.56 ampere. I'll stop this video here. Next video I'm going to solve another example. Thank you.